Here we'll show you how to fit a quadratic growth curve model using the Stata SEM builder. And here we have just a basic growth curve, linear growth curve model. And we have here our intercept, and it's all ones across each time point. And here we have our slope, and it's linear, so we have 0, 1, 2, 3, 4, 5, and 6. And the data that this is internalizing problems of children from ages 10 on to ages 16. And so I fit this linear model, and here you can see the mean of the intercept is 0.404, and that's significant. And then the mean of the slope is negative 0.003, and that's not significantly different from 0. So from this we would conclude that they don't significantly change over time. And then we want to do a test to see whether or not there was significant variance in that, though it doesn't appear to be a lot of variance in that, though that might still be significant. So again, from this we would conclude that there's no significant average change over time in the child's internalizing problems. But what we'd also want to look at is the fit of this. So we've hypothesized this linear model. Now we want to see whether or not our hypothesis actually matches the data very well. And so here I've gotten our fit statistics, and our RMSEA, as you can see, is very poor. That's a bad fitting model by RMSEA standards, but also by CFI standards, it's also a bad fitting model. It's below 0.9. We'd like to see that above 0.95. So we find that our hypothesis of linear growth doesn't seem to match the data that we have. So now let's go ahead and fit a quadratic model. Maybe the rate of change isn't the same from age 10 to age 16. Maybe that's curvilinear. So then all we'll have to do here is we go and we add a latent variable, and we're going to call this quad because it's a quadratic term in this. And again, we're going to estimate the mean of that because we're really interested in estimating that mean. Now what we're going to do is we're going to add all these paths from quadratic to all of the indicators of internalizing problems at these different time periods, just how we have it with the intercept and we have it with the linear slope. And in fact, I'm probably going to rename this from slope to linear slope because it helps me keep things straight. Not that I necessarily have to do that, but I like to have that L linear slope because technically this quadratic variable here is also a slope. It's just a quadratic slope. And so what we're going to do is we're going to make this the quadratic effect of this. And so the slope here, the linear slope, the effect of this linear slope on this one is 0. And so the corresponding one from the quadratic, we're just going to square that, and of course the square of 0 is 0. Now we have here, we'll go on to this next one. This slope is constrained at 1, and so the quadratic slope, we're just going to square that, and again that's going to be 1. The square of 1 is 1. Now for this next one, this next one at age 12, it's constrained at 2. Now the square of 2 is 4, so we're going to add 4 in there. And this one, the corresponding linear slope is 3, and so we're going to constrain this at 9. The corresponding linear slope for this is 4, so 4 squared is 16. And the corresponding linear slope for this is 5. 5 squared is 25. And the corresponding linear slope for this is 6. 6 squared is 36. And there we have it. I'm going to correlate the intercept with the quadratic slope. Again, we'd expect that the rate of change over time is going to be related to the intercept. And we'd also probably expect that the linear slope is going to be related to the quadratic slope. So we're going to add in those covariances and estimate those as well. So let's go ahead and estimate this model. Okay. Now what we have here is you'll see we have our mean intercept, slope, linear slope, and quadratic slope. Now notice that this intercept is the same as it was before, but our linear slope is actually quite a bit different. It's actually significantly larger, and it is significant. So there's a significant linear slope, and there's also now, with our added thing here, the significant quadratic slope. So when we added in the quadratic term, it changed our model estimates quite substantially. Sometimes when you add in the quadratic slope, you'll see the intercept and the linear slope, they don't change at all, but this has really changed our model quite a bit, changed our linear slope quite a bit. Again, the intercept wouldn't change though. But the linear slopes changed quite a bit, indicating that there probably really is some curvilinear growth going on here. And again, here we have the variances of those. Now let's look at our goodness of fit statistics. I'm going to go back here and just re-click on estimate our goodness of fit statistics and see what these look like. You can see now our RMSEA is really not too bad at all. 0.068, that's a little bit higher than ideal, but that's still pretty good. And our CFI is now 0.96. So that increased about 0.07 for the CFI. We now have a much better fitting model that now that we've added the quadratic slope. So you would definitely conclude that yes, there is a curvilinear relationship going on with child internalizing problems from age 10 to age 16.